This is Balanand Pinni, student at Georgia Tech for cybersecurity. I'm presenting a paper on biometrics. Let's look at it from the definition. What is biometrics? So biometrics consists of two parts. One is bio, another is metrics. Bio is something related to physiological or a unique attribute. Metrics is the measurement part. These attributes are used to identify a person, to authenticate and authorize, and this would help to identify a person uniquely with 100% accuracy, with no false negatives, and to be very difficult to forge such identities. And these are used in case of defense and highly secured areas within the United States, like atomic centers, thermal power stations, and the secured areas. Data biometric authentication is done with the process of comparing person's characteristics with existing template. And if there's a match of the unique characteristic, we say person's identity is confirmed. And this identity is compared against the existing database where the person's identification was already recorded. So you can have a good comparison, and which does not change over the period of time. We see that there are certain threats, why we go for such biometric trends, which are implemented at the large scale because of crime and terrorism. And there is identification. It it is sharing by the authorities, the authorized authorities, so that they could authenticate very quickly and it will be with more accuracy. Now look at what are the physiological measurements we are talking about. It could be the shape of a hand, or it could be a finger, or a vein, or it could be a pattern. It could be some pattern in the vein, or iris or retina, for example, or eye characteristics. In case of criminal justice, a DNA from blood or saliva could be used to identify a criminal by a team of forensics. This is considered as more stable through the lifespan of the individual. There are two types. One is static, one is dynamic biometric. We are talking about static biometrics, which doesn't change over the period of time, like a face or a fingerprint or a hand or an iris or a DNA, which are unique. And the other thing is behavior, which changes a little bit by keystrokes or signatures or voice, which could change a little bit. But whereas the physiological face, fingerprint, hand, and iris and DNA doesn't change. Biometrics had been in place for a very long time, since the Chinese 2nd century BC. A French police officer who was also a researcher who applied anthropological techniques of anthropometry in a law enforcement, creating an identification system based on physical measurements. So we all know the photography was invented quite long back, and it was supplemented with fingerprinting in those days already. There were also, we are talking about the mug shots, which are taken as a photography of a criminal, which began in 1840s and later until they standardized as that of standardizing process of doing criminal investigations and collecting the biometrics. In US, it was in 1902. India, it was done by New York Police, FBI 1924, UK 1901, it was the Metropolitan Police. In French, it was in 1902 to identify the criminals. Now we are looking for measurement of unique patterns, and this was done during World War II. The Allied forces used this method to identify the senders and the authentic messages they received. So you know that they're identifying who is sending those Morse codes with dots and dashes. There are three kinds of biometrics we are talking about. One is what you have, what you know, and what you are. And we are talking the third type. The first type is what you have. It could be like a RAS token or something. Second, or soft or a hard token. Something it's a password. And something you are is a physical traits. That's the one which you're talking about, which individual possesses in his life cycle and does not change. Let's look at benefits of biometrics. This method guarantees the level of accuracy with the individual. The error rate is very low, as said by Francis, that if you look at the two similar fingerprints, it would be 1 in 64 billion. You can imagine the error rate is so low. But it is not 100%, 100 to 100% perfect. It's still, but the rate is so low that still it is acceptable, at the acceptable limits. And the areas where we use this biometrics are law enforcement, border control, healthcare, and voter registration. Law enforcement, we already spoke about the police, case of police, and where they can catch the criminals using DNA or saliva or the blood DNA and attach it to the crime. Border control forces with people going in and out of the country, they look at the facial recognition system nowadays. The first time it was done in Atlanta, where face recognition system was implemented, is being implemented. Healthcare system is also implemented in the United States, and also finally the voter registration system, where we want to make sure the voters are not duplicated, the votes are unique, and they're not duplicate votes. So it's a unique identification of a person apart from passport and uh, driver's license, which you use in the United States. The risks that are identified and the data that's being transmitted can be captured, can be fraudulently replicated. So the data that's getting transmitted, you can take the data and transmit it fraudulently, and they can be replicate the whole data. And if you are giving to the third party, they can use it for some other purpose than what it is given for, as per the consent of the person or from the attorney general. So there's something called consent order that's given by each state for United States. For it is Attorney General at New York. He provides certain consent orders that the biometrics used to be used only for a specific purpose. You cannot use it for some other purpose. So there's a risk that people could uh, uh, use it for some other purpose if they're given if they get their hands onto the database. There are certain data files that are binding certain regulations and guidelines as per UN Resolution 1990, and also certain European regulations, which is in May 2018. The data protection regulations you cannot share with some other country. The data cannot go out of Europe and stored in other countries. So these regulations have to be kept in mind when you're using biometrics. Biometric authentication is done through various methods. One is called retinal scan, which is images which produces the blood vessels pattern, a light sensitive surface of lining of the inner eye, the iris recognition, where you see at the pupil, as the ring shaped region around the pupils. Then finger scanning, where finger is scanned for raised areas or branches in the human finger image. And some of the branches we are talking about finger trails where the certain identification various gaps within the lines of the fingerprinting, and they take 8 points as per the FBI, minimum 8 points of differences. The other things are like finger vein ID is based on vascular pattern in the individual finger. So looking at the vascular pattern, so we are talking here about the picture recognition using algorithms, which actually captures the images of the picture and then calculates the patterns and pushes it for making sure that it is been compared with the existing prints that are available. The facial recognition is similar way. We identify 80 nodal points on the human face. On fingers, we call it as traits. On face, we call it as nodal points. In voice recognition system is another way as per the individual shape of the mouth or the throat rather than other variable conditions. Um, uh, Many of these are used in IVR, the voice recognition systems, to make sure the person who is calling is an authenticate person. And it is also various tools that have been identified in the case of voice identification system. Going further, there's a lot of research that has been done in the face of biometrics where they used sclera. It's a white part of the eye, not the pupil or the retina. So a third factor attribute where the blood vessels patterns are recognized, and they write a lot of algorithms to store that patterns within the database, like fingerprints to identify the branches and the ridges. Just now we spoke about the ridges, where 9 ridges the maximum they take, minimum 9, because more than 8 it should be, as per the US law, and confirming this in terms of patterns and then comparing with the existing one through algorithms. These algorithms are written so that they're developed to identify, to process the images. Due to chemical accidents, these images can be altered. These musicians, they use their fingers that can be altered.